Okay, so we're doing example 1 on page 207. So what we're doing is we're solving each trigonometric equation in a specific domain. So we're going to solve this, and then we're going to look for the answers in this area off of our unit circle. Okay, so all we're doing is solving this as if we're solving for x. Okay, so it's just a simple solving for x equation. So if sine was x, we would want it by itself and everything else away. That's the same idea as what we're doing now. So what we're going to do is we're going to write the rest of the equation down because I didn't. There we go. I was wondering why that didn't look right. Okay, so now we're going to get all the sine stuff on one side, the numbers that are alone on the other side. Okay, so let's subtract this 3 sine onto this side. Okay, so we have 5 sine, subtract 3 sine. That leaves you with 2 sine. Okay, and we still have a plus 2 here, and we still have a 1 on the other side. Okay, so then what we're going to do is we're going to subtract the 2 over to get him so that the numbers are together. So we have 2 sine is equal to 1 minus 2 is a negative 1. And then just to finish it off, we'll divide by 2 and divide by 2. So we have sine is equal to negative 1/2. Okay, and so this is saying we're looking for where sine is negative 1/2 on a full rotation for the whole unit circle. So if you look on your unit circle, all you have to do is look and see where sine, remember our sine values are, if this is cos, the second one is sine, right, on our unit circles. So where is sine a negative 1/2? What was it? I heard it somewhere. 7 pi over 6. And 11 pi over 6. Perfect. Okay, so for b, we're doing the same thing. This is our equation. We have 3 cosecant x minus 6 is equal to 0. And our interval is from 0 to 360. So that's still an entire circle around. It's just we're talking in degrees instead of radians this time. So instead of having answers in radians, we'll have answers in degrees. Okay, so what we're going to do is we will add our 6 over to get it away from our cosecant. Whoop. There we go. And then we have to divide by 3. So we get cosecant x is equal to 2. Okay, and keep in mind we don't have cosecant on our unit circle, but we have sine, right? And cosecant and sine are reciprocals of each other. So if our answer is cosecant x equals 2, then it's actually sine x is equal to the reciprocal, which is 1/2. So now all we have to do is look where sine is equal to 1/2 on our unit circle, and we're going to say our answers in degrees instead of radians. What is it? 30 degrees and 150 degrees is your answer. Okay, so example 2 is we're solving again. Our equation looks a little more complex, but if we look past the tans, it's actually something we're very familiar with, so it's not a huge deal. And our answers are going to be back in radians because we're talking our interval is anywhere from 0 to 2 pi on our unit circle. Also, it says give exact answers where possible. So if these things fall on a unit circle, you can give an exact answer. But if it doesn't, then you just got to bust out the calculator and do an approximate answer. Okay. So if we're looking at this, does this look familiar to anybody? Not with the tans, if they were something else? Right. Okay, so it would look like x squared minus 5x plus 4 if you were imagining those x's instead of tans, right? So it's the same idea. All we're going to do is we're going to factor this equation. Okay, so if we were doing it this way, we would want what multiplies to 4 and adds to minus 5, right? And it would be minus 4 and a minus 1. So usually we would write x minus 4 and x minus 1, right? But this time we actually have tans. So I'm just going to write it as tan minus 4 and tan minus 1 is equal to 0. Okay, so then we should solve each of these pieces. So it would be tan minus 4 is equal to 0 and tan minus 1 is equal to 0. So if we add this over, we get tan is equal to 4, and we add this guy over, we get tan is equal to 1. Okay, so tan 4 is not something that shows up on the unit circle, right? If we have whole values, they're 0 or 1. So we're going to have to do an approximate for that one. So you would switch your calculator to radians, and you would go tan 4. Okay, so on your calculator, make sure you go second or shift tan because we're looking for angle. This angle is going to be in radians, so make sure your calculator is in radians. So we'll go second tan 4 is equal to, and you should get 1.32 decimal stuff. Okay. So then if we have tan is equal to 1, we should be able to find that stuff off of the unit circle. Okay, so we need to think of Sir Coxer ticks. Okay, and we know that. Okay, so we're trying to see where tan is equal to 1. There's two kind of ways we can do this. If we were in degrees and you wanted to know what 1 was equal to in degrees, which is probably the easiest way to figure this out, you could go second tan 1, make sure your calculator's in degrees, and then it'll tell you what the actual degree is when tan is 1. And we get 45. Okay, so that's one way to do it. Also, if you were looking at your unit circle, we know that tan is equal to sine over cos. Okay, so if tan is equal to sine over cos, do you notice on the 45 area, the sine and the cos are both the same? They're both root 2 over 2. So if you went root 2 divided, or root 2 over 2 divided by root 2 over 2, you would get 1. Okay, so that's another way you can tell. If you were looking for the points that were the same, sine and cos are the same there. So when they're divided, which makes tan, then that would get you 45 degrees. Yeah. Okay, so since we know that tan equals 1 is 45 degrees, we now know where to look for our radian answer on our unit circle. So where tan is 45 degrees, that's pi over 4. And it would also be where they're both negative, which is 5 pi over 4. Okay, so our answers to this question are going to be 5 pi over 4. Whoops, I forgot the pi there. Pi over 4, 1.32, and we still have one more because it should be 4.46.